Okay, here we go. Lesson 7, looking at percent word problems. We'll just kick it off with some examples. Example 7.1 says 18 is 20% of what number? Well, how I would like to solve these is by doing, and you may have your own way, but by using a ratio box, because we love ratio boxes. Now we look at this part. It says 18 is 20%. 18 is 20%. That means those correlate. So I can say 18, this is kind of an is line, 20%. Now if this is my percent column, percent is always out of 100. That would make this blank 80, because 20 plus 80 is 100. But now I have my percent column, because it says 18 is 20%. Now I want to know of what number. So it wants to know the full percent, so therefore, that would be our blank that we are looking for. 18 is 20% of what number? So then we solve with our ratio. 18 over x equals 20 over 100. I'm going to go ahead and reduce this and cut down to 0. I'm going to go ahead and reduce 2 over 10 to 1 over 5. Less work in the end. And when we cross multiply, we find that x equals 5 times 18, 90. So 90 would be your answer. Simply using the ratio box to solve. We'll look at one more. 1500 is what percent of 250? A little bit different. Change the wording. Let's start the same way we did the last one. Here's our percent column. It says 1500 is what percent? I'm going to write what percent since we don't know that part, but we are clearly going to be looking for that. What percent of 250? Well, remember our percent column is always out of 100. So naturally, we would be putting the 250 in the total column. It's going to seem odd that 1500 is greater than your total in a sense. That just means your percentage is going to be greater than 100. It is always possible. I mean, say you made $100 this year and $1,000 the next year. Well, you had what would that be? Like 500% increase, actually be more than that, of how much money you made next year compared to this year. But anyways, point being, you can have a greater percent. So then we solve. We don't need that column or row. 1500 over 250. Let me go ahead and cut out a 0. Equals what percent of 100? And then we solve. 150,000 equals 25 times our variable. 25 times our variable. We divide. Oh, sorry. It would actually be 150 times 100 be that. Then we divide by 25. And see that our answer is 600. So the percent is actually 600. And that would be your answer, and that's how you solve. So those are some percent word problems. Now let's just look at some, we're just refreshing on some equations from geometry. Just going to do some examples just to, have a little throwback Thursday here. Example 7.3 gives us 2x plus 2 for angle A, that for B and C. Now just so you know, because they have a degree sign outside the parentheses, we always know that we're talking about degree and not side lengths, or sorry, angle measure and not side lengths. Well, if you remember, we're trying to find x. But how we're going to solve this is by using the triangle sum theorem. Triangle sum theorem, all three angles add up to be 180. So that would be 2x plus 2 plus 7x plus 18 plus 6x plus 10 equals, running out of room, 180. Now we can add like terms. 2x plus 7x, that'd be 9x, plus 6x, that probably looks confusing, 15x. All I did was add 2x, 7x, 6x. So 15x plus 2 plus 18 plus 10 equals 180. Add these common terms. 2 plus 18 is 20, plus 10 is 30. Yeah. Now, subtract the 30. 150 equals 15x. X is 10. Right here. So that's triangle sum theorem. Just a little refresher from geometry. Now let's look at 7.4. Looking at parallel lines cut by transversals. It says find x, and then it actually wants us to find the measure of a small and large angle. If you remember, when we have parallel lines, all these lines are parallel, that's what those arrows mean. When we have parallel lines, it cuts all of these angles into small and large angles. All the small angles are the same. All the large angles are the same. So small angles are congruent. Right here, 3x would be an example of a large angle, or sorry, small angle. 4x plus 33 would be an example of a large angle. So how do we solve if we have a large and a small? We would, well, if they're parallel, we know that large and small angles here would be supplementary. So we could say 4x plus 33 plus 3x equals 180. Supplementary equals 180. Add like terms. 4x plus 3x, 7x plus 33. Subtract 33, 147 equals 7x. Ooh, that would be 21, I believe. So x equals 21. That's one part of the answer, but it also wanted to know small and large angle. So to find the small, 3 times x would be 3 times 21. That would be 66. So you got 66 degrees. And however you wanted to solve for the other, you could subtract it from 180. Or you could plug in 4 times 21 plus 33. And when you solve that, you would get 107. Sorry, this is 63 degrees actually. This would be 117. So you would have 63 degrees and 117 degrees. And that would be how you would do transversals with parallel lines. And let's look at one more. 7.5, they try to get a little tricky, try to get fancy. It says the measures of angles A, B, C, D are in the ratio of 1 to 2 to 4 to 2. And solve. It's like, okay, how do we solve this? Well, if they're in the ratio of 1 to 2 to 4 to 2, that corresponds with A, B, C, D. So if I wrote it like so, A is 1, B 2, C 4, D 2. I write it that way. Maybe that helps you see it a little bit better. If we just know the ratio and we don't know the numbers, we can just tag an X on the back of all these and plug them in here. And so what we could turn this into was we could say X would be 2x, 4x, and 2x. Notice I went backwards because this thing went backwards. Then went A, B, C, D. They went backwards. So how do we find x? Well, this is a straight line, and we know the straight line is 180 degrees. So we say 180 equals the sum of all these. 2x plus 4x, 6 plus 2, 8 plus 1, 9x. You divide and solve 180 divided by 9. X equals 20. X equals 20. And then you plug all that back in. So what we find? A, B, C, D. So A is 20. B is 20 times 2, 40. 20 times 4, 80. 40. So those would be your answers. And yep, that's a little geometry throwback there. But that is the end of Lesson 7.